Hello, geometry. Alright, we're going to take a look at elevation and depression. We did this with our little activity today, so this should go fairly quickly. It's all about application problems too, so those will take a little time, but we're going to use our SOHCAHTOA stuff to help us find some lengths and angles using angles of elevation and depression. So we'll start real quick. So an angle of elevation is an angle formed above your horizontal reference line. Okay, so an angle of elevation is above, it's elevated above something. An angle of depression is an angle formed below a horizontal reference line. So if I'm hanging out outside, doing some math, so I'm happy, and my line of sight is my horizontal reference line. So where my eyes are is the horizontal distance. When I am looking up at this cool little bird hanging out here, right? Looks just like a bird. Then the angle that is formed right here is the angle of elevation. If the bird is hanging out, its horizontal reference line becomes parallel with my horizontal reference line and creates a congruent angle of depression from its location. As you can see, we end up making some right triangles, and this is a vertical height. Vertical height. Okay? Angle of elevation, you find your horizontal line. If your angle is above that horizontal line, it's angle of elevation. If I find a horizontal line next to the angle and the angle is below it, it's depression. So basically what we're getting at though is you can use angles of elevation and depression as the acute being the angle less than 90 degrees, as the acute angle in a right triangle formed by horizontal line and vertical height. We're just back to right triangles and using SOHCAHTOA to find some measures. So let's do some examples. It says example 1, identify the given angle as an angle of elevation or depression, then find the value of x. So we find the angle, our reference angle that we're talking about. There goes the bell. It is next to this horizontal line. It is above it, so it's an angle of elevation. And we want to solve for x. X is opposite is this side. X is the hypotenuse because it's opposite the right angle. I have an O and an H, so I jot down SOHCAHTOA, O and H, that's so I'm going to use sine. Sine of 62 is equal to the opposite over the hypotenuse, which is x. To solve for x, I got to multiply both sides by x, and I get x times sine of 62 equals 94, but x is still not by itself, so I divide by sine of 62. X is equal to 94 divided by sine of 62. Okay, so really what happens when I have a variable in the denominator and I'm solving for it, that comes out and I just switch places with the other side of the equality. Okay, so we can skip the step by step if we can remember that. When the variable's in the denominator, I just switch with my other side of the equality. I substituted in my calculator as 94 divided by sine 62, and I get x is approximately 106.5 feet. if your calculator is not set to degrees under your mode, you will get a negative length. A negative length doesn't make sense. So that makes you stop and think, oh wait, what needs to be changed? And in that case, it's because you're not on degrees. So make sure you're in degrees. All right, let's do the other one. We have a reference angle of 44. This is the horizontal piece. The angle is below the horizontal, so this is an angle of depression. I have a right angle here, so this is opposite, and x again is the hypotenuse. I have an opposite and a hypotenuse, O and an H. Again, this is a sine problem. Sine of 44 is equal to the opposite, which is 100, over the hypotenuse, which is x. X is in the denominator, so the chi-chi way is just to switch places. X is equal to 100 over sine of 44. X is approximately, when I put it in my calculator, 144 feet. Again, you'll get some strange number if you are not in degrees. Make sure you are in degrees. Alright, you're going to pause the video for the next two problems. You're going to identify some angles, and then you are going to find x and y in the problem below. Okay, there are your answers for your practice problems. If you did not get them right, make sure you pause the video, work on your math, figure out what happened. Alrighty, let's go to the next page. The rest of the lecture is all about applying this, application problems, in context. That's what angle of elevation depression is useful for. So we want to do a bunch of in-context practice problems. So we're going to look at a wind farm. Wind farm is those great big huge windmills that produce energy. Suppose you stand 53 feet from a wind farm turbine. So a wind farm turbine. So I know I got these huge thingies, and I know it comes way down. And it says that I stand 53 feet from. So if I'm standing up, we're going to be on the same ground as the wind turbine. But remember, when I'm looking, I need a horizontal. So my 53 feet is already partway up above the bottom. It says I'm standing up. So it's 53 feet here. This is where my right angle is. So this is the piece that I need to add after I find the other piece of the height. So I am 53 feet from the wind turbine. Your angle of elevation to the hub of the turbine is 56.5. Elevation, that must be up. So this is 56.5 degrees. Your eye level is 5.5 feet above ground. So this is where that extra 5.5 feet that you're going to have to add into the problem to figure out what this whole height of the turbine is. Approximately how tall is the turbine from the ground to its hub? So we are looking for this piece. Remember, I have to find x and add 5.5 to it because I am at a horizontal with my line of sight. So let's identify the pieces that we have. We know this is the reference angle. Across from the reference angle is my opposite. And then this side is right next to it, so it's the adjacent. If I do so, TOA, I have an O and an A. So O and an A is tangent. I set up my trig ratio. Tangent of 56.5 is equal to opposite, which is x, over my adjacent, which is 53. I solve for x by multiplying both sides by 53. And I put in my calculator. I get approximately 80.1 feet. But remember, that's just x. That's this piece. I have to take 80.1 plus 5.5 to find the entire length. So my turbine is 85.6 feet tall. Okay, let's try another one. Let's take a look at an airplane that is landing in Oklahoma. So to approach runway 17 of the Ponca, something like that, City Municipal Airport in Oklahoma, the pilot must begin a 3 degree descent. Descent's going down. So from the airplane, I need a horizontal line. So my angle of elevation or angle of descent or depression is 3 degrees. It's below the horizontal line, so it's a descent. But the horizontal is parallel to the horizontal, so I know that this angle is also going to be 3 degrees. The airport, 3-degree descent starting from a height of 2714 above sea level. So somewhere down here is sea level. And from all the way down here, sea level is 2714. The airport is 1,007 feet above sea level. So the airport is 1,007 feet above sea level. To the nearest tenth of a mile, how far from the runway is the airplane at the start of the approach? So I need to set up a right triangle with the pieces of information that I need. I know that that's 3 degrees. Looks like 33 degrees. I know my airplane, I'm looking for how far above the airport he is. So this whole thing is 2714. So I need to take away 1007. So over here I'm going to do 2714 minus 1007. That's going to equal 1707 feet. So if I have the whole thing as 2714, I back away this piece. This piece is what I have left. That's my 1707. How far from the runway is the airplane at the start of its descent? So I am looking for the airplane at the start of its descent, how far it is from the airport. So we are looking for the horizontal distance. So we take a look and see what we got. Okay, this is my right angle, so this is my opposite. This is right next to it. It's not the hypotenuse, so it's adjacent. Again, I have an O and an A. So if I'm looking at SOHCAHTOA, an O and an A is tangent. So the tangent of 3 is equal to the opposite, which is 1707, over the adjacent, which is x. Remember, when your denominator has the variable, you can switch places with the other side of the equality. So x is equal to 1707 over tan 3. Substitute that into your calculator, and you get is approximately 32,500 and what's it say? To the nearest tenth of a mile. 32,571.5 feet from the airport. Okay. All right. The next, actually the rest of the lecture is for you to practice. Sketch your drawings, figure out where your reference angle is, and set up the appropriate trig ratio. Be real careful about what they're asking, and make sure you're drawing a picture, because that will really help you. So you should pause your video now, work through your practice problems, and then check your answers. I'll display those. Okay, here are the first 3 practice problem answers. Go ahead and pause your video, work through, check your answers, and then push play while I switch over to the other page. Okay, here is the answer for number 4. Pause the video if you did not get it right. Take a look at it. I don't have enough room to display all of them, so I'm going to shoot this up. And there's the answers for number 5. Again, pause the video, check your answers, make sure you have your setup correct. If you have any questions, jot them down now, and then come see me in class, and we'll talk about your questions. Okay, thank you.